which has been divided into 12 equal parts. If you were there last time, you know how we can divide into 12 parts. If you are here today, you will know again how to divide this circle into 12 parts. Then you will see there's some curve that looks something like this. Now this curve is ending somewhere like that. Then they've told you you have half pi d. I just want this to make sense. This pi d, where have you seen it before in mathematics? Circumference, right? So if we just multiply it by 2, we have the full circumference. Eh? So remember the concept I was talking about. Imagine this is the thread that you are trying to unwind. Right? So if it's here, you start untying it, it will be creating this path. If you untie it fully until you reach somewhere here, you would have used up pi d. You get what I mean? Eh? If you unwind it fully, you are going to end up with using up a space from somewhere, pi d. If it's a square, the same thing will happen. You are supposed to have your total distance. If this is 10, meaning your total perimeter is like 40, you need to use that 40. If you look at the method there, this picture here can help you realize what to do. The first thing you need to do is have a diameter for a circle. I'll give you a sample question. You can write it down or just dictate it. So we are going to construct an involute. Construct an involute of a circle 35 millimeter in diameter. Construct an involute of a circle of 35 millimeter diameter. Simple question, right? You've been given the diameter. From that diameter, how do we get the half point? It's 35. What's 35 divided by 2? Mathematicians. 17.5. Can you measure 17.5 accurately in drawing? It's very difficult to get the midpoint. Eh? So what you do is, I talked about this. I actually did it here. I'll utilize the top part of this paper board. Let's say we are working. I'm drawing with reference to this line. Eh? So if you have a t-square, what you're doing essentially is that you have your t-square on the board. Then on top of your t-square, you draw a line like this. Try to draw it a bit on top of the paper because we'll be using a lot of space. Then using the same t-square, you put it like that, then have a line that intersects properly, somewhat at 90 degrees. For me, I'll use this line that I had here as a reference. So what we have here is just the center. Remember last time I was saying whenever you draw a circle, you need to have a center line. A center line is a line that is composed of a short and long dash. Eh? So here we can have a line like that. Usually you don't want to end in short dashes, but here just for illustration purposes, that's fine. This is the center line. A full one will start with long, short, long, something like this. Don't have enough space there, but you can continue a line so that you have a long, short, long combination. You always want to end with a long dash. So this will be our center point where we want to have a 35 divided by 2. Remember, we need the radius. So what you do in drawing, you can just find a place somewhere on your paper Or if you want, you can bisect like we did and then draw this line here. You mark a point like that, then get your 35. I'll make it slightly bigger so that you can see. So let's say this is 35. You remember what we said we do is just bisect. Eh? So somewhere on your paper, you just do this so that you have an accurate 35. So now the distance from this point to there is exactly in the middle of 35. So this is 17.5. Then you stand here and draw your circle. This circle is in construction. And then we'll have to divide it into 12 equal parts. After you're done with this, you can even rub it out. It's not really necessary. What I just didn't want here is to have a lot of arcs and the like. So after we do that, we'll get our 36 set square, this one here. You make sure you use a T-square at this stage so that you are parallel to this line. So you put your T-square, it will look something like this. For me, I already have this line to refer to. So I'll just imagine this is my T-square. Then you get your 3060. We'll just be rotating it in. I'm starting with this position here. I draw a line through the circle, like that. Then I rotate it. You can even rotate it counterclockwise. Usually I advise you keep going clockwise. So we rotate like that. We have another line. Then notice with this side I can also make a different line. Then I rotate it one last time. And I have my 12 parts. You can start counting them from anywhere, but for us to draw with reference to what we have in your assignment there, you can talk about this maybe as point 1, this as 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and point 12. Now, the next stage here is very critical. If you look at your drawing there, you see there are some lines. Fine. There are some lines that are helping us to draw our involute. I'll ask you to have or pay much attention. What we're going to do here is we'll start making 90-degree angles. 90-degree angles with these divisions that we had. So we'll make a 90-degree line at point 1, at point 2, at point 3, at point 4, 5 until we reach 12. Right? I'll show you an example. For example, at 1, how do I make a 90-degree? What you have to do is, you've seen this 45, this angle is 90. So I want to make a line here that will go in this direction. What we're assuming is we're starting to unwind from here. We've got a small string, and then we start from here. We start unwinding it. We want it to be unwinded like that. So to help us to do the unwinding, we'll use this set square. We'll align it with point 1 like that, making sure the 90 is on this line. We'll get our other set square. We slide just a bit so that when we move it upwards, we're going to have a line this side. We slide it until it reaches 1, then we draw. So we've drawn a line that is at 90 degrees from point 1. We'll do the same at point 2. So we keep repeating this procedure. When I reach point 3, I'll show you why you are doing this. So point 2, we move it this side. Then we slide such that we can draw a 90 from point 2, like this. Then we do the same at point 3 here. We align our lines like this. Then we can just slide going up. If possible, sometimes you can just even slide on this same side, like this. And then you draw a line going up. Why are we doing this now? Why we're doing this is we'll get our distances. Remember when getting this line here from 1, we're imagining we are going to get the rope that was on this circle and start taking it this side. Right? So we stand at this point 1 where the 90 is coming from and open to the point where we're saying we're assuming the rope is coming from, like this, and then we'll draw an arc. So you draw an arc like that until it touches the line you drew. The next is you go to point 2 and then open to where you ended, like this, until you touch the line coming from point 2. You go to point 3, you open to where you ended, like that, and then you strike an arc until you touch the line coming from point 3. So whenever you're stretching, whenever you're drawing these lines, you want to ensure they are long enough so that when you're drawing, you can have where they'll end. So I'll draw the line that is supposed to come from point 4, supposed to be at 90 degrees. I can also use this for the 90s. So I'll align it such that my 90 is at that line. Then I'll slide it. I'll slide it going all the way this side. Then I'll slide it like that. I can see point 4 now. Then I'll draw a line going all the way like that. Remember, our goal is when we have this point here, we start from the previous strike like that. We keep doing this over and over again. What I've found is very helpful is you just making these lines go at 90. The quickest way to do that is this way. It's a bit confusing when I show you at first, but this time it will make much more sense since you've gotten the idea. You notice just by playing around with this set square that there are some points where if you just move it like this, for example, at point 7, I have a perfect 90. This is just mathematics, but I won't go into that. For example, I rotate at point 5, I'll have a 90. Or even when I'm just like this on the T-square, you can see that I have a 90 at 6 and I have a 90 at 12. So we'll make use of that for us to be fast. So at 5, I won't start moving all that. I'll just do that. I want one at 7. I'll just rotate my set square until I have something that looks like a 90. Make sure you're using a t-square for this, or else your, your angles won't be the way they are supposed to be. If I want one here, I'll keep rotating until I see something that looks like a 90. For example, when I rotate up to this point, I can have a 90. Whilst it's still like this, you can also see I have a 90 here. If I rotate it again, at 10 I can have a 90, but I'm too much at the bottom, so I'll avoid doing that. Let me make the 90 for 6 so that we draw the arc until it comes here. Using your t-square, you can draw this. Imagine you have a t-square like that. Just need to go to 0.6. If you don't have a t-square, just find the line that's like this. It'll be somewhere here. And then draw like that. You can always extend these lines. By the way, these lines went in the direction that they were not supposed to be, but we'll bring them back to the correct one. So we ended at 4. If you've forgotten, just try to do that. So we go to 5, open like that. This is a very simple question once you know what to do. Like that. This is the path our thread would take. Then I'll stretch this. I'll extend. Supposed to be on this side. The same as this one here. Anyone confused? Sense. These lines here are not very necessary. We need one at 10 and 11, but before we do that, I'll just draw the arcs. That's supposed to be here. I think we ended at 6. So we go to 7, we open to this here, like that. We go to 8, we open here. We go to 9, we open like that. So if you draw it too much at the bottom, you're not going to have this space enough to draw everything. So I'll keep drawing until I have the point at 12. We have ended at 9, so I want 10. Just like I was explaining, you just need the t-square. So you place your t-square. You want the line to come this side. So you keep rotating. This is looking like it's at 90 at 11, but I want the one at 10. This is the point and the angle that I need, like that. I'll do the one for 11 in advance. And then I'm just left with the one for 12, which is not difficult. Using a t-square, you just go to point 12 and draw a line like that. Now I'm going to extend this one from 10. The one from 11. And finally the one at 12. So now, remember earlier we're talking about pi d somewhere. I'll now show you which distance is supposed to be pi d theoretically. Because there's error here, it won't be pi d, it will be slightly less than pi d. So we have that point 11. Is this the correct one? At 9 we were here. Did I get the correct 10? Yeah, it's supposed to be here. Then we move from 9, go to this point. So 9 ended here. What's supposed to be here is the one for 10. 10 is here, and it will start from where 9 ended, like that. Then 11, like that. You can see already I'm also missing some space. Hopefully to touch just right there. But yeah, you can see I don't have enough space. I was supposed to move this slide to this side. So on your paper, you'll be able to have the last point here. That will touch. So now the distance from here to that imaginary point that will be here, the point is somewhere here. So the distance from here to here is supposed to be theoretically pi d. But it won't be pi d because of approximation. There's one approximation that we've made. We have not used an infinite number of divisions. If we used a lot of divisions, we would have had pi d when we reach here. But because we didn't do that, we assumed 12 equal parts. Right? That's just a polygon. So we'll have slightly error. But as long as you do this, you get the marks for making your involute. That's how we make an involute. You notice the direction of your lines, these ones are rubbery, can change the direction of your involute. What I mean, I'll explain. Let me just remove these lines. The circle here, we have the line there. If these lines were in the other way, meaning they are not starting from here, going like that, if I draw them in this other direction, this involute will open from the other side. You get what I mean, right? It won't start like that. It can also be the other way around. And it always doesn't start from this top point. It can even start from there. You can start from here. You can start from there. You can start from anywhere. As long as you remember how we start, if you can imagine you want it to start from here, the next point will be point 1. So we'll make a 90-degree line like this, and then get the distance from 1 to where we are starting from. Draw an arc. You get your point 2. Draw a 90-degree line. Open to where you ended at point 1 until you reach on the line where 2 is. If you can remember that procedure, you'll be well and good. Everything else will be making sense.